Hello everyone, welcome back to my YouTube channel. I'm Bhumikavi, pursuing my computer science and engineering from Sri Venkateshwara College of Engineering, Bangalore. Today I'm here to talk about the subject computer-aided engineering drawing, where I'll be dealing with the topic Introduction to Computer-Aided Engineering Drawing. Let's move on to the topic. So, first of all, let us know what is computer-aided engineering drawing. Computer-aided engineering drawing is a technique where engineering drawings are produced with the assistance of a computer, and with manual drawing is only the graphical means of representing a design. Let us know more about CAD, that is computer-aided engineering drawing. Engineering drawings are used to communicate design ideas and technical information to engineers and other professionals throughout the design process. An engineering drawing represents a complex three-dimensional object on a two-dimensional or four-dimensional piece of paper or computer screen by a process called projection. An engineering drawing is a type of technical drawing that is used to convey information about an object. A common use is to specify the geometry necessary for the construction of a component and is called a detailed drawing. Usually, a number of drawings are necessary to completely specify even a simple component. These drawings are linked together by a master drawing. This master drawing is more commonly known as an assembly drawing. The assembly drawing gives the drawing numbers of the subsequent detailed components, quantities required, construction materials, and possibly 3D images that can be used to locate individual items. Although mostly consisting of pictographic representations, abbreviations and symbols are used for brevity, and additional textual explanations may also be provided to convey the necessary information. The process of producing engineering drawings is often referred to as technical drawing or drafting, which is also known as drafting. Drawings typically contain multiple views of a component, although additional scratch views may be added of details for further explanation. Only the information that is a requirement is typically specified. Key information such as dimensions is usually only specified in one place on a drawing, avoiding redundancy and the possibility of inconsistency. Suitable tolerances are given for critical dimensions to allow the component to be manufactured and function. More detailed production drawings may be produced based on the information given in an engineering drawing. Drawings have an information box or title block containing who drew the drawing, who approved it, units of dimensions, meaning of views, the title of the drawing and the drawing number. Let us know the importance of engineering drawing. Drawing plays a vital role in the engineering and construction works. The drawing requires no language, anyone can read it. So, drawings of other countries' structures can also be studied easily. The drawing improves the imagination and new inventions can be developed. The estimate for the project can be done using the details provided in the drawing. The structure can be analyzed completely before construction by using drawing. So, every engineering construction department, especially civil engineering, requires drawing to start a project. Let us know what are the uses of CAD. Computer-aided design, which is also known as computer-aided engineering drawing, is one of the many tools used by engineers and designers and is used in many ways depending on the profession of the user and the type of software in question. CAD is one part of the whole digital product development, which is shortly known as DPD activity within the product lifecycle management, shortly known as PLM processes, and as such is used together with other tools, which are either integrated modules or standard alone products, such as computer aided engineering, which is also known as CAE, and finite element analysis, shortly known as FEA or FEM, and it is also used in computer aided manufacturing CAM, including instructions to computer numerical control, which is CNC machines. and it is also used in photorealistic rendering and motion simulation. Document management and revision control using product data management, that is PDM. Let us know what are the instruments used in engineering drawing. The instruments used in engineering drawing are as follows: set squares of 30 degree, 60 degree and 45 degree, protractor, it could be circular or semicircular, pencils of grades H and HB, a pocket knife or blade, and it also includes eraser, sketchbook, microtip pencil, French curves and rota scale. Quadrants play a very important role in engineering drawing when you are drawing manually. So let us know some basic information about the quadrant. A quadrant is a region defined by the two axes. As we all know, it is x-axis and y-axis of the coordinate system. When the two axes x and y-axis intersect each other at 90 degrees. The four regions so formed are the quadrants. These regions include both positive and negative values of x-axis and y-axis called coordinates. The coordinates represent the position of a point in a quadrant. Here is the representation of the quadrant. This is a very easy representation and it is very easy to understand. So I have taken this image. So here is the quadrant system. I mean here is a x and y axis line. As we all know, this is x axis, this is x dash axis, and this is y axis and this is y dash. So this is quadrant 1, this is quadrant 2, this is quadrant 3 and this is quadrant 4. So quadrant 1 is 0 degree is less than theta and it is less than 90 degree. Quadrant 2 as 90 degree less than theta is less than 180 degree, and quadrant 3 as 180 degree less than theta is less than 270 degree, and quadrant 4 as 270 degree less than theta and less than 360 degree. Here is the quadrant system which is represented in the engineering drawing. As we all know, in first quadrant, the HP and VP are represented, and in first quadrant it is represented as above HP and in front of VP. In second quadrant it is represented as above HP and in behind VP, and in third quadrant it is represented as below HP and behind VP, and in fourth quadrant it is represented as below HP and in front of VP. So this is first angle, this is second angle, this is third angle, and this is fourth angle. So let us know what are the type of lines used in engineering drawing. This is the continuous thick line which is used in visible edges of an object, and this is continuous thin line which is used in projection lines, leader lines, dimension lines and outlines of revolved sections. And this is dashed thick line which is used in hidden outlines. This is dashed thin line which is used in hidden edges, and this is called as continuous thin freehand line which is used in limits or boundaries of partial or interrupted views, and this is known as chain thin line which is used in lines of symmetry, trajectories and center lines, and this is called as chain thick line which is used in indication of lines and surfaces for which particular treatment is required, and this is chain thin double dash line which is used in the alternate and extreme position of movable parts, centroid lines, initial outlines, outlines of adjacent parts prior to forming. And let us know some important points that need to be remembered. That is, thickness of XY line in the computer drawing should be 0.35 mm, and thickness of thin line should be 0.13 mm, thickness of thin line should be 0.50 mm, and thickness of point, as we all know, it should be 2 mm, and thickness of projection line should be 0.13 mm. And front wave, top wave and side waves are represented in the engineering drawing when we are drawing either manually or on the system. So the front wave should be represented as A dash, B dash, C dash, D dash and so on. Top wave is represented as A, B, C, D and so on. Side wave is represented as A double dash, B double dash, C double dash, D double dash, and so on. Thank you. So let us solve some problems for better understanding. Here is a question which says the front view of a rectangular lamina of sides 30 mm into 20 mm is a square of 20 mm sides. Draw the projections and determine the inclination of the surface of the lamina with HP and VP. Here the main aim of the question is to draw the projections and determine the inclination of the surface of the lamina with HP and VP. By the way, this question is from the topic projection of planes. So let's solve this question. So first of all, we have to draw the XY line. XY line will always hold the thickness of 0.35 mm. Now draw a straight line, that is XY line of 0.35 mm. Now go to text command, select text, name this line as X and Y respectively. Now let us solve the first part of the question, that is the front view of a rectangular lamina of the sides 30 mm into 20 mm is a square of 20 mm sides. Now we have to draw a square. So select this rectangle and select the XY line. Now give the width as 20 mm and height as 30 mm. Press enter. We'll get a square. Make sure it is placed properly on the XY line. Now select these lines and give it the thickness of 0.50 mm. Do this for this line also and make it as 0.50 mm. Now go to text command, name this corners as A dash, properly as A dash. This is D dash and this will be B dash and this is C dash. Now what you have to do is go to smart dimension, measure this line, this corner, which should be 30 mm and this should be 20 mm. Now let us solve the rest of the problem, which is we have to draw a XY line. Select the thickness of 0.35 mm. Draw a XY line here, the X1 Y1 line. Now go to text command, name this line as X1 and this line as Y1. Now what you have to do is go to line, select the thickness of 0.13 mm. Now what you have to do is you have to place a square of 20 mm sides. So select a square and make sure it will be placed on the XY line. Give the width as 20 mm and height also as 20 mm. Place it properly on the XY line and select the corners and give it the thickness as 0.50 mm. Give it as 50 mm. Select all the sides and make it of the thickness 0.50 mm. And for this lines as well. Now go to line command, select the thickness of 0.13 mm and extend this line. Extend this line and now go to text command. We had to name this square, right? So Name it as A dash, and this as B dash, this as C dash, and this will be D dash obviously. And now go to smart dimension, measure this line which should be 20 mm. Now what you have to do is draw a 45-degree line below the XY line that should extend like this. Now go to line, select the thickness of 0.13 mm, go to angles, give the angle as minus 45 degree. As you're drawing below XY line, press enter. So give it as minus 45 degree, press enter. Select this line and draw a 45-degree line. Now select angle between and measure this angle. Make sure it is 45 degree. Yes, it is 45 degree exactly. Now what you have to do is extend these line as well. Go to line, select the thickness of 0.13 mm and extend from this point as well. Right click on the line to place it properly and extend these line also. Now what you have to do is you have to draw a 42-degree line. First of all, let us draw the arc. Go to arc by center point, and what you have to do is you have to select this radius up to here and draw an arc. Yeah. Now you have to draw a line of, the degree which holds 42 degree. Now go to line command, give the angle as 42 degree. Press enter. Now first of all select this line and extend this where it touches this arc. So make sure it is a straight line. It should touch this arc as well. Now measure this angle. Make sure it is 42 degree. Go to angle between and select this and this line. So make sure it is 42 degree. Yes, it is 42 degree. Now measure this angle as well. So this should be 48 degree. Select this line and this line. This is 48 degree exactly. Now we have got the problem and we have solved the problem properly. So what you have to do is you have to make this line as a thick line. So go to select option, select this line and give it the thickness of 0.50 mm. Give the thickness of 0.50 mm. Now name these lines. So go to text command. Now what you have to name is here, that is A dash, D dash. Now you have to solve the rest of the problem, which is you have to draw a square here. So go to line command and select the thickness of 0.13 mm. You had to extend this arc, the end of this arc, extend up to 45-degree line and extend to the left side. And what you have to do is select the thickness of 0.50 mm, extend this line as well Now extend this line. Make sure it is 0.50 mm. Now go to text command. Name this line as B. This is C. And this is A. And this is D. So we have got the perfect answer for this question. So here the problem ends. So let's move on to the another question. So here it is already solved. Now let us solve it once again. So remove all this. Try to solve this problem. Problem says that a point R is 25 mm above HP and 20 mm in front of VP. Another point S is on HP and 30 mm behind VP. The distance between their projectors measured parallel to the line of intersection of VP and HP is 50 mm. Find the distance between the top views of points R and S. So by the way, this question is from the topic projection of points. So let us solve this problem once again for better understanding. Go to line command, select the thickness of 0.35 mm and draw the XY line. Make sure it is a straight line. No, it's not straight. So go to select option and trim it. Now go to line command and select the thickness of 0.35 mm and draw a straight line. Make sure it is a straight line. And now what you have to do is you have to name this line as X and Y. So go to text command, name this line as X and Y respectively. Now again go to line command, select the thickness of 0.13 mm. Now we are going to draw the projection lines. So projection lines will always hold the thickness of 0.13 mm. Let's solve the problem. So select this line, give the measurement as 25 mm. Press enter, you will get a line of 25 mm. Then again select the XY line, give the measurement as 20 mm. Press enter, you will get a line of 20 mm. Right click on the line to place it properly and make sure it is a straight line. Now you have to mark the points. So go to point and select the thickness of 2 mm. Remember the points always holds the thickness of 2 mm and place these points at the end of this line. Now go to smart dimension to measure these lines. This should be 25 mm and this should be 20 mm. Now let us name these points using text command. Name this as R dash as it is the front wave and name this as R. So this is top wave. Now what you have to do is you have to measure 50 mm and now go to line command, select the thickness of 0.13 mm, select this XY line, give the measurement as 50 mm, press enter, you will get a 50 mm line here and you have to solve the rest of the problem. So let's solve it, which is the point S which lies on HP and 30 mm behind VP. So give the measurement as 30 mm, press enter and you will get a line of 30 mm. Make sure it is a straight line. Right click on the line to place it properly on the XY line. Now let us mark the points. Go to point and select the thickness of 2 mm. As we all know, points always hold the thickness of 2 mm. So place it properly on the line, I mean the ends of the line. Now let us name these points using text command. This will be S as it is the top wave, and this is S dash as it is front wave. Now let us measure this line and make sure whether it is 30 mm or not. Yes, it is exactly 30 mm. Now measure this line, which should be 50 mm. Yes, it is 50 mm. Now we have to join these top waves so that go to line command, select the thickness of 0.13 mm and select this point R and draw a line which touches the point S, and you have to measure this line using smart dimension. Go to smart dimension and measure this line. This is 70.71 mm. So we have got the answer as 70.71 mm. So we have found out the distance between the top views of points R and S, which is of 70.71 mm distance. So here, for your convenience, you can write it here as the distance between the top views of points R and S. So we can write it below. So the distance between the top views of points R and S is 70.71 mm. For watching. Please do like the video, share, comment and subscribe to my YouTube channel.